we have planned to cover some formulas and more questions, so to help you have a grasp over all these concepts. So in that way, today we will start with projectile motion, and in this video I will tell all the important problems, all the important formulas that you have to remember. So now let's start. So in this projectile motion, it is nothing but you are throwing a particle into the air, such that it has it has its parameters, kinematic parameters in both x and y axis. This comes under motion in plane, so it involves both x and y axis. So when you throw a particle with initial velocity you can divide its velocity into two components when it is in two-dimensional motion. So if theta is the angle it is making with the horizontal x, so you could divide this u into u cos theta and u sin theta. So this is nothing but the horizontal velocity and this is nothing but the vertical velocity. So now first of all we will see t is equal to 2u sin theta by g. This is nothing but time of flight. So what is time of flight? Time of flight is nothing but the time taken to cover the entire projection, to the entire horizontal distance where the ball drops. So from this place you are throwing a ball, and at this place it comes to the ground. So this total distance is called as range, and time taken to cover this range is called time of flight, and its formula is given by 2u sin theta by g. This u sin theta is nothing but vertical component of velocity, and the next formula says t is equal to capital T by 2. So this t is nothing but time taken to reach the maximum height. So this is what we call as maximum height covered by the particle in projectile motion. So the time taken to cover the horizontal distance till maximum height is what we call as small t, and it is nothing but half of time of flight. So this time is nothing but half of time of flight. So the next formula is h max. H max is nothing but u square sin square theta by g. So the maximum height is given by the formula h max is equal to u square sin theta by g. So the range, the next is the range. So range is given by, according to the equation of motions, we can write s is equal to ut plus half at square. Since there is no acceleration along the x direction, we could neglect this term. So it is s equal to ut. So the velocity along the x direction is nothing but u cos theta. So we could say that instead of this you could put u cos theta, and the time taken to cover range is nothing but capital T. So I could use this like I could use the range is equal to u cos theta into t. If you derive this, if you expand this equation, you will be getting u square by g into sine 2 theta, and you could also write sine 2 theta as sine theta is equal to 2 sine theta cos theta. And for the next point, this is quite important point, and you could also use in maximum problems to simplify some steps. So it is nothing but you are actually throwing two projectile, one with theta 1, one with an angle of projection theta 1, and another with an angle of projection theta 2, such that the ranges of both the projectiles are same. So they have equal ranges for two different angle of projection. If that is the condition, they vary. The both angles are complementary. So both angles will give you theta 1 plus theta is equal to 90 degrees. So if you want to find other angle, you could use if you want to find theta 1 and theta 2 is given in question, you could use 90 degree minus theta 1. So the point is here is for two different angle of projectiles, the ranges will be same if both angles are complementary. And next is nothing but the trajectory of the equation. So when we say trajectory of an equation, trajectory of a particle, we use an equation that is involving y and x. So you could actually derive this equation. It's quite simple. So in the projectile motion, there is an horizontal velocity u sin theta. So and there is an acceleration due to gravity which is acting in the downward direction. So you could use that y is equal to, according to equation of motion, s is equal to ut plus half at square. So I could use for the horizontal distance y is equal to u sin theta into t minus half gt square, because acceleration in the downward direction, so minus half gt square. And for the x direction, I could actually use x is equal to we know that along the x direction the velocity is u cos theta, so u cos theta into t, and there is no acceleration along the x-axis, so we could neglect this term. So now we have to find the trajectory. So trajectory is nothing but an equation involving x and y. So now we have to eliminate this t term from both the equations in order to bring an equation that is involving x and y. So I could use this t is equal to x by u cos theta. Now I could substitute here. So y is equal to u sin theta into t. Instead of t, I will be substituting x by u cos theta, and minus half into g into, instead of t square, I will be using x square by u square cos square theta. And now we know that this un will get cancelled. The sin theta by cos theta is nothing but tan theta. So x tan theta minus half g x square u square cos square theta. So this is how you bring this equation. I have just explained this derivation, and I didn't explain derivations for other formulas because they are so simple, and this formula it's so volatile that you might forget at some point. So you just know the trick how to bring the equation. So I explained. And this trajectory can also be written in the another form, y is equal to x tan theta 1 minus x by r. So this r is nothing but range. So you have to bring an equation in such form so that this denominator term will be the range. Or even in some questions they would directly give an equation in this form, and you could easily find a range from this denominator. So I think I have covered mostly all important formulas. Even if something is left, I will cover that in our problem. So we will see more problems from projectile motion, and I will cover mostly PYQs and different models, just to ensure you cover all possible models. So thank you.